Okay, good morning everyone. So today let me start with module 5B. Module 5B, that is three-phase induction motors. It's a small module. So three-phase induction motor. So first let me take brief introduction. So three-phase induction motor works on three-phase electricity. So this is the black box of three-phase induction motor. Three-phase IN. So it works on three-phase AC. So power input to a three-phase induction motor is three-phase AC supply, and power output P out going to be mechanical. Okay. So for motoring operation, the power flow is from left to right. Left to right. For motor operation. And the same motor or the machine can be operated in generating mode provided you interchange the type of input. If you give, this is from right to left, this is for generating action. If you are P in is P mechanical, your P out going to be P electric. On the other hand, okay, if your power input is electrical, then your power output going to be mechanical. Okay. So just like your synchronous generator, what you have is a three-phase induction machine, and this three-phase induction machine can be operated in motoring mode by giving input as electrical and getting output as mechanical. Or the given induction machine can also be operated in generating mode by giving input as mechanical power and getting output as the electrical power. Okay, so this is your normal machine operation, which holds good for AC machines as well as DC machines. Okay. Now, when it comes to motor, okay, on the basis of supply, motors can be classified into two types: DC motor and AC motors. DC motors and AC motors. In AC motors, you have further two classifications: synchronous motors and induction motors. Now, motors are used everywhere, right? So, can you give me a few applications of motors? Motors are used in chemical plants for mixing the chemicals. Motors are also used in, let's say, rubber plants for mixing the natural rubber with chemicals. Motors are used in houses for in fans, mixer grinders, washing machines, etc., etc. So you can say that in all the electrical appliances, electric motors are the widely used electric equipment, right? Now, you have different types of motors, as discussed, DC and AC. And AC, you have synchronous motor and induction motor. out of all these motors, 90% of electric motors are induction motors. That means to say 90% are induction motors. The remaining 10% could be DC motors or synchronous motors. Now the question is why? When we have the other types of motors, why the world is using the induction motors? So quite evident, right? Because the induction motor should have some distinct advantages over the other types of motors. Okay. So let us discuss the advantages of induction motor. Advantages. So when I say advantages, these advantages are compared with the counterparts such as synchronous motor and DC motor. The first advantage of induction motor is that high efficiency. High efficiency. The induction motors, operate at a very high efficiency. Efficiency, as high as 85%. The second advantage is that high power factor. You have seen in module 2 is that when the power factor is higher, you can say that the power conversion is better. That means to say, with a high power factor, the equipment exhibits higher efficiency. And when you say higher efficiency, you can say lower the losses. So the induction motor works at relatively higher power factor. The power factor is normally close to 0.9, which is very, very good. The third advantage of induction motor is that very robust construction. Robust construction. Robust or rugged construction. And the fourth advantage of induction motor is that you can say that simple starters can be used. So starters are the devices which are used in order to start a given electric motor. You have different types of starters. You have starters for DC motor. You have different types of starters for induction motors and synchronous motors. Now, if you compare all these starters, you can say that the starters which are used in induction motors are very simple compared to the other types of starters. Okay. And the fifth advantage, probably you can talk about the maintenance. Maintenance is less. Maintenance is less. That is, the operating cost of induction motor is very, very small. And probably you can even write the sixth advantage is that induction motors are self-start. Induction motors are self-starting. In a sense, the moment when you connect three-phase AC supply to an induction motor, the motor starts to rotate, which is not true for synchronous motor. So the moment when you connect AC power supply to a three-phase synchronous motor, the synchronous motor will not start, provided you give some auxiliary starting mechanism. Okay. So these are the major advantages of induction motor compared to the other motors. When you say advantages, it also has some disadvantages. So one of the major disadvantage of induction motor is that it is kind of constant speed motor. kind of constant speed motor. Constant speed motor. And the second disadvantage is that starting torque is less compared to DC. So these are the major disadvantages of induction motor. Essentially, they are constant speed motors, and the starting torque is less compared to DC motors. Okay. Now, somewhere here we are mentioning, right, the starting torque is less compared to DC motors. If that is the case, why people aren't using DC motors? Why people are still using induction motors? That's because the DC motors suffer from high maintenance cost. DC motors suffer from high maintenance. So, there is a trade-off between starting torque and maintenance. So operating cost will be less if you go for induction. Okay. So due to the more advantages, you can say that in world, out of all the motors, 90% motors are induction motors. In short, IM. IM stands for induction motors because of all the advantages. Okay. All right. So that being a brief introduction of induction motors. Okay. So for short notes, they can ask what are the advantages and disadvantages of induction motor compared to the other types of motors. Next, we have the construction. So the construction is somewhat similar to the three-phase alternator in the sense induction motor. Throughout the discussion, while writing something on the board, I will be using IM. Okay. IM stands for induction. Okay. Now, the induction motor is consisting of two major parts. Stator and rotor. Induction motor is consisting of two major parts, stator and rotor. The symbolic representation could be something like this. The outer part is the stator. Okay, this is not a detailed construction. This is kind of a symbolic construction. The outer part is the stator, okay, which is stationary, as the name suggests, and the inner part is the rotor. Okay, this is the shaft. This is your rotor. The stator and rotor is separated by a small clearance. Now in the diagram, the clearance is shown as quite big, but in reality, the clearance is very, very small. The clearance between stator and rotor is called as air gap. Air gap. Okay. So this air gap is very, very small. It is up to 3 mm for high capacity machines. High capacity motors. Okay, this air gap is very, very small. Sometimes you can also say that hairline air gap. Okay. On the other hand, for high capacity machine, it is up to 5 mm. Okay, up to 5 mm for high capacity machines. Okay. What is air gap? Air gap is nothing but clearance between stator and rotor. Why do you need air gap? You need air gap so that your rotor can run free. If there is no air gap, what will happen is your rotor is going to touch with stator, and it can produce a lot of mechanical noise, which should be avoided. All right. And what should be the clearance of air gap? It should be very, very small, as small as 3 mm for high capacity motors and 5 mm for, let's say, low capacity. Okay. My bad. This is low capacity. Low capacity. Okay. So air gap, okay, basically facilitates the mutual induction. So air gap basically facilitates mutual induction. Okay. So like your transformer, the induction motor works on the principle of mutual induction. Okay, mutual induction, wherein electric supply is connected to one part of the circuit, which is the stator. Okay, and due to the connection of electricity at the stator side, what happens is that EMF gets induced in the rotor. So that can be treated as mutually induced EMF. And the principle on which the induction motor works is nothing but the electromagnetic induction. All right. Fine. So that's about the very basic or primitive construction of induction motor. Okay. Now let us look at the detailed construction of induction motor. Now, while explaining the construction of synchronous generator or alternator, I had mentioned one important point, right? I had mentioned that the stator of alternator is similar to the stator of induction motor. That means to say you don't have a separate stator for induction motor as well as alternator. The same stator can also be used in alternator. So that's the reason stator construction I am not going to discuss. If at all you have missed the stator construction, well, I would suggest you to watch my video. So in the video, I have discussed about the stator construction of alternator. Okay, so please refer the stator construction of alternator. It is ditto. It's ditto same. All right. So that's about the stator construction. So stator, okay, just to recall, stator is consisting of stator winding, and stator winding is three-phase winding because the given induction motor is a three-phase induction motor. So stator winding is consisting of three-phase winding, that is R winding, Y winding, and B winding. B winding. To the stator winding, three-phase AC supply is connected. All right, because it needs electricity, right? Your motor requires electricity as the power input. So power input is nothing but three-phase electrical supply given to the three-phase winding of the induction motor. And the construction you can read from the stator construction of alternator. Okay. So that's about the stator construction. Now let's come to the rotor construction. rotor construction. Now, the rotor is divided into two types. Okay, so on the basis of rotor construction, your three-phase induction motor can be classified into two types. The squirrel cage rotor, squirrel, it's the small mammal, right? Squirrel cage induction motor. Okay. And the second type of induction motor is slip ring. Slip ring, sometimes it is also called as wound rotor induction motor. Induction motor. Okay. So you can have two types of rotors, squirrel cage rotor and slip ring rotor. Accordingly, the induction motors are called as squirrel cage induction motor and slip ring induction motor. Okay. So first let us consider the construction of squirrel cage rotor. Okay. As the name suggests, the rotor should resemble a cage construction, right? The same cage which was used to, keep squirrels inside. Okay, squirrel cage or bird cage. Okay. Now, squirrel cage rotor construction. So let me draw the two views. Okay, so front view. Front view. You don't have to draw the three-dimensional view. Okay, two-dimensional views are sufficient. In the front view, the squirrel cage rotor looks something like this. Yeah, I can show you the diagram also. Okay. So if you can see, so this one, this is your squirrel cage rotor. So in the front view, what you can see the shaft. So this is the shaft. And forget about this. This is the enclosure. All right. The enclosure, you keep it out because it is not the part of your rotor. It is just the protective cover. Okay. So this is your shaft, and this is your squirrel cage rotor. Okay. These are bearings. That small ring is nothing but your bearings meant for reducing the friction. Okay. Now in the front view, you can observe the rotor core. So this is your rotor core. Okay. The same thing I'm going to draw in the board. So in the front view, what you can see is the rotor core. Rotor core. And also the shaft. Shaft. Okay. So this is the shaft. Okay. And this is your rotor core. Okay. Now, I also want you to look at these two. Right? Can you see at the rotor, at the edges, there are two silver colored ring shaped objects. One ring is over here and the other ring is over here. The silver colored objects are called as the slip ring. So in the front view, those objects have been drawn in a rectangular way. So these are your silver colored objects. So they are called as end rings. Okay, I'm sorry, I have to attend an important call. All right. So the silver colored objects which I have shown in the textbook are nothing but end rings. Okay. Now these two end rings are connected with several rotor bars. Okay. So these are all rotor bars. Okay. So the red colored ones are rotor bars. Let me color it so that it gives an enhanced visibility. Okay, these are all rotor bars. Rotor bars are sometimes it is also called as rotor conductors. It's one and the same. Okay. So these are rotor bars. Okay, rotor bars are pretty difficult to observe in the textbook diagram. So what I will do soon after this class, I will send some images to the class. Okay. So the red ones are rotor bars or conductors. Okay. These rotor bars are either made up of aluminum or it is made up of copper. Okay. Why aluminum? If you are looking for a cheaper induction motor, then you can go for aluminum bar rotor simply because aluminum is you know inexpensive compared to copper. If you want high efficiency motor, then you can go for copper. Okay, so there are two types of rotor bars. So these rotor bars are sometimes called as rotor conductors. Rotor conductors. So in squirrel cage induction motor, you will not find rotor windings. What you have is bars of rotor. Okay, solid bars of rotor. Okay. Now, of course, rotor is circular in shape, and rotor is constructed with rotor bars. Okay. You cannot simply place the bars, right? You need some supporting mechanism to hold these bars. So to hold the bars together, you are using end rings. So end rings are meant for supporting the bars. All right. So this is what the construction of squirrel cage rotor looks like. Okay, this is the front view, and I can also try to draw the top view. Top view. In top view, you will be able to appreciate the squirrel cage shape. Yeah, but in exam, you don't have to draw the top view. All right. You don't have to draw the top view. So these are the bars. So as you can see, the three-dimensional diagram can throw some more light, right? Now the rotor looks like a cage. Okay. So since the appearance of the rotor is taking the shape of a cage, the name is called as squirrel cage. squirrel cage. Okay. If possible, you try to draw this diagram in the examination. If you are not able to draw, it's fine. You can just draw this diagram, provided you show all the parts. Okay. So this is your end ring. Okay. The ring-shaped object, which is found on the top half and the bottom half, is called as end ring. Okay. So rotor bars are braced or welded to these end rings. Okay, BRAZED, braced or welded. Okay, to the end rings. Okay, so this is how the rotor construction of squirrel cage rotor is carried out. Okay, so as you can see that the rotor bars are permanently connected to the end rings. You don't have any provision to add extra resistance to the rotor circuit. So basically, rotor resistance cannot be varied. Why you cannot vary the resistance? Because there is no provision to add extra resistance into the rotor. So that's the reason, your squirrel cage induction motors are also called as constant speed motors. Constant speed motors. Because in induction motor, there is some dependency between rotor resistance, okay, R suffix small r, rotor resistance and speed of the induction motor. Okay, there is some relationship between rotor resistance and speed. If you cannot vary the rotor resistance, you can say that you cannot vary the speed. Hence, the induction motor based on squirrel cage rotor is called as constant speed motor. So this is one of the disadvantage of induction motor, that the induction motor is essentially a constant speed motor. Okay. Now, what is its effect on real-time application? Let's say, for example, you want to build an electric car, okay, or electric vehicle. So in electric vehicle, you don't want constant speed, right? You want to vary the speed from few RPMs to several thousands of RPM, right? Few RPM is during the starting the vehicle, and thousands of RPM while cruising at, let's say, 60 or 80 kilometers per hour. So if your application is something like electric vehicle, then you cannot use such an induction motor because you cannot vary the speed. Now, in such cases, you have to go for an induction motor in which you can, you will be able to vary the speed. So that is your the second type of induction motor. So slip ring or phase wound rotor will have the provision to add external resistance. By adding the external resistance, what you can do, you can vary the rotor resistance. By varying the rotor resistance, you will be able to vary the speed. So the induction motors which are used in electric vehicles are basically the slip ring induction motors or phase wound induction motors, because electric vehicles requires variable speed. On the other hand, the induction motors which are used in constant speed applications such as mixers and let's say fans, okay, wherein you don't have to vary the speed much. So you can go for squirrel cage induction motor. So based on the application, one can go for squirrel cage induction motor, or you can go for slip ring induction motor. So it is always on the basis of application. Okay, so that's about the construction of squirrel cage induction motor. Okay, now I want you to pay attention to figure 1. Okay, in figure 1, you can clearly observe that the conductors or rotor bars, okay, how they have been kept. They have been kept in such a way that the bars are non-parallel to shaft, right? So these bars, are they in parallel with shaft axis? No. Okay, shaft axis is along x-axis. On the other hand, these rotor bars have been kept at some inclination angle. Now, this is called as non-parallel nature of rotor bars. So, by keeping the bars of the induction motor such that the bars are non-parallel to the shaft, okay, you can achieve two major advantages. Okay, and the non-parallel nature is called as skewing. So, in literature, they say that the rotor bars are not parallel to shaft axis. Instead, the rotor bars are skewed, and the process is called as skewing. Okay, so skewing is nothing but the non-parallel nature of rotor bars. Okay, now by keeping the rotor bars non-parallel to shaft axis, first of all, you can avoid magnetic locking. Magnetic locking between stator and rotor. Okay, magnetic locking. So magnetic locking is a phenomenon at which the rotor latches onto the synchronous speed of the stator winding. Okay, so you will not get any variable speed action. The rotor simply rotates at synchronous speed. Okay, which has the other adverse effects. Okay. That is not so important at this given point of time. Okay. So magnetic locking can be avoided. Magnetic locking between stator and rotor can be avoided by skewing the rotor bars. And the second one is you can reduce magnetic noise. Reduce magnetic noise, and the operation becomes very smooth. The operation becomes very smooth. Okay, so in exam, for short notes, they can ask why the rotor bars are skewed, why the rotor bars are not parallel with the shaft axis. So you can say that rotor bars are skewed in order to achieve the two following advantages. The first advantage is we can avoid the magnetic locking between stator and rotor. And the second advantage is that we can expect a smoother or noise-free operation by skewing the rotor bars. All right. So that is your construction of first type of rotor, which is called as squirrel cage induction motor. Okay. Now let us consider the second type of rotor, which is called as slip ring rotor or phase wound rotor. Slip ring rotor or phase wound rotor. Now, in phase wound rotor, as I have mentioned, okay, that you should be able to vary the rotor resistance. So that's the reason the phase wound rotor is not constructed with rotor bars. Instead, phase wound rotor is constructed with windings. Okay. So you will have a star connected winding. So these are not bars, these are windings. And this winding is basically kept on shaft axis. Okay, so this is your shaft axis. Or it is kept on shaft, you could say. This is your shaft. Your shaft. Now, this shaft will have three slip rings. Okay, slip rings. First slip ring, second slip ring, and the third slip ring. Slip rings are nothing but the circular shaped copper conductors. So these are slip rings. Okay. Why three slip rings? Because there are three windings: R winding, Y winding, and B winding. Okay. Now, one end of the slip ring is connected to the rotor winding. Okay. So, say for example, this is connected to this. This is connected to this, and this is connected to the third slip ring. Okay. One end of the slip ring is connected to the rotor winding. So, okay, this is your rotor winding. That's the reason I have drawn in the form of a coil. Coil refers to RL circuit or the winding. The other ends of these slip rings, okay, the other ends of the slip ring are connected to brushes, okay, carbon brushes. So these are carbon brushes, and these brushes are later connected to a star connected external rheostats. Okay, so these are variable resistances or rheostats. All right. So this is connected to say this. This is connected to say this, and this is connected to this. Okay, this is your star connected rheostats or variable resistances. Okay, so these resistances can be varied between R maximum and R minimum. Okay, so these resistances can be varied between maximum resistance value and minimum resistance value. Okay, so that addresses the problem which was encountered in squirrel cage induction motor. In squirrel cage induction motor, since the rotor circuit was kind of short circuit by means of end rings, you never had any provision to add external resistance. But if you look at the slip ring rotor construction, as you can clearly observe that, external resistances can be added into the rotor circuit, and these resistances can be varied between R max and R minimum. You can say that the rotor resistance can be varied. By varying the rotor resistance, speed can be varied. All right. So that's the reason such a motor can be used in variable speed applications such as electric vehicles, electric locomotives, escalators, lifts, cranes, etc., wherein you require higher starting torque as well as variable speed. So squirrel cage induction motors are low torque motors. On the other hand, slip ring induction motors are high torque motors. Okay, that is the first difference. The second difference is that squirrel cage induction motors are constant speed motors. Okay, and slip ring induction motors are variable speed motors. Okay, and the third difference is that squirrel cage induction motor doesn't have any frictional elements such as brush and slip ring assembly. So that's the reason your squirrel cage induction motors are also called as maintenance-free motors. In the sense, very low maintenance is required for squirrel cage induction motors. On the other hand, if you look at the construction of slip ring induction motor, you can see that the slip rings are present along with carbon brushes are present. And these slip rings and carbon brushes, constantly rub against the fixed resistance, right? Okay, so basically resistance are connected to slip rings via carbon brushes. So these brushes are constantly, in contact with the slip ring. So due to this constant rubbing, there can be wear and tear in brush assembly as well as slip ring assembly. So frequent maintenance is required, and frequent maintenance invites additional maintenance cost. So this is high maintenance machine, and slip ring induction motor is low maintenance machine. So these are the major differences of slip ring induction motor and squirrel cage induction motor. All right. So that's the difference part. All right. Fine. So that completes the construction of slip ring induction motor and squirrel cage induction motor. Very, very important. They can ask the construction in exam for 6 to 8 marks. Okay, very, very important. Finally, we can talk about the applications. So few applications I have already mentioned. So sometimes they will ask, mention few applications of squirrel cage induction motor and slip ring induction motor. So first we will write slip ring induction motor. And here let us write squirrel cage induction motor. Now, slip ring induction motors, as you have seen that, resistance can be varied. Since you can vary the resistance, torque can be varied. All right. Hence, they are used in high torque. Okay, you can say instead of high torque, variable torque. That sounds better. So they can be used in variable torque, variable speed applications. Variable speed applications. On the other hand, the vice versa condition you are supposed to write under squirrel cage induction motor, resistance is fixed. And due to which torque cannot be varied. Torque cannot be varied. So that's the reason they are used in fixed speed applications. Now when we say applications, what are those applications? So applications, okay, can you tell me the variable speed applications or variable torque application? Lifts, hoists, cranes, electric vehicles, etc., etc., and constant speed applications such as mixers, blowers, okay, and blowers, fans, and probably you can use in pumps, etc. Okay, so these are the major differences of the slip ring induction motor and squirrel cage induction motor along with applications. Okay, other differences I have already mentioned. High maintenance, low maintenance. Okay, and slip rings are used, slip rings are not used. Rotor resistance can be varied. Rotor resistance cannot be varied due to the short circuit nature of rotor. Okay, so that concludes the first half of three-phase induction motor. Okay, so in tomorrow's class, let us look at the working principle and the generation of rotating magnetic field in induction motor. Okay, so I'll stop it here. Thank you.